boys and girls. I have not met you for quite some time. Today is the first time I am taking for 3 classes, one class of 3 sections, class 7A, 7B and 7C. The chapter number 1 and other chapter was taken by Mr. Kevin before. Now today I will be taking chapter number 2 and I will finish this chapter. Till I finish I will keep taking this class for all the 3 sections. Is this clear? Whatever the teaching has been done by computer studies, either by me or by Mr. Kevin, okay, is meant for all the 3 sections, 7A, 7B and 7C. Is this clear? Yeah. Today I am going to begin a fresh and a new chapter called as number system. Number system, chapter number 2 of your textbook, right? 2 of your textbook, number system. I'll let you know what is this number system is all about. You and I have the habit of using the numbers 0 to 9. 0 to 9. That's why we call it as a decimal number system. Decimal means 10. Ternary number. Some author they say ternary number system. Some they say decimal number system. Decimal means 10. Where everything is, we will be using only 10 digits. 0 to 9. In other words, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many digits are they put together? 9 digits. Sorry, 0 to 9, 10 digits are there. Done? So that's why you and I from our kindergarten studies till now, we are familiar with one number system known as decimal number system. What number system is that? Decimal number system. What do we call? Deci means 10. In other words, what the base would be? Base is 10. Why do we use base 10 is? Because we hardly use 10 numbers. Just now I told you 0 to 9. How many of them are there? 10 of them are there. Right? How many of them are there? 10 of them are there. Right? Your computer, name it. A desktop or a mini computer, microcomputer, mainframe computer, laptop, palm top, handheld devices, name anything. It doesn't use one number system. Instead, it uses 4 number system. How many number systems do they use? 4 of them. But you and I are familiar with only one number system known as decimal number system, whose base is how much? 10. Why do we call base as 10? Because we use 10 numbers. There are other 3 more number systems which are there, which computer is very familiar, which I am going to introduce today. What is the first number system is? Decimal number system. The second number system is binary number system, whose base is 2. Why do we call this one 2? Because it consists of 2 digits. That's why the base is, what are the digits we have? 0 and 1. Right? We have the third number system, which is known as an octal number system. As you all know, octal means 8. Right? Octal number system, whose base would be how much? 8. Why do we call the base is 8? Because we are going to use 8 digits. What are they? 0, 1, 2, 3, 4, 5, 6 and 7. 0 to 7 we use 8 numbers. That's why the base is 8. The last one is The last one is called as hexadecimal number system. Hexa means 10, deci means 10. 10 and 6 would be 16. So what is the base would be? Base is what? Base is what? 16. This is something strange. You need to pay attention, boys and girls. Here not only we use the numbers, we also use the alphabets. They are 0 to 9 as we have done. How many of them are there? 10 of them are there. 0 to 9, 10 of them are there, right? Afterwards, we have 6 alphabets: A, B, C, D, E and F. Should I repeat? Should I repeat? What do you mean by hexadecimal number system? Hexa means 10. Octal means 8. Right? Hexadeci. Deci means 10. 6 and 10 would be 16. How many digits are there? 16 digits are there. Whose base is 16? I will elaborate to you. Right? We have 10 digits. In mathematics we write 1 0 as 10. We represent. If you want to write 14, 1 4 we write. Right? Here in hexadecimal we don't write 1 0 as 10. 10 is represented by A. 11 is represented by B. 12 is represented by C. 13 is D. 14 is E and 15 is F. 0 to 15, how many of them are there? 16 of them are there. Is this clear, boys and girls? Let me repeat again. What did I tell you so far? You and I are familiar with only one number system known as decimal number system. Right from our kindergartens till our schooling, college, post-graduation, then followed by research. Whatever you do, we will be predominantly using only the decimal number system. Deci means how much? 10. What is the basis? 10. Why do we keep this one as basis 10? Because there are 10 digits are there. 0 to 9 of them are there. Mind you, boys and girls, you and I have the habit of counting from 1. Computer doesn't do like this. Always the counting starts from 0. Right? Now, the next one, this is the first number system. In fact, I want to write the first, second, third and fourth. Because you are familiar with this decimal number system, I will tell you. The next number system, the second number system is known as binary number system, whose base is how much? 2. Why do we call this one as 2? Because it has got only 2 digits, zeros and ones. Zeros and ones. These binary numbers play a vital role in any of the electronic gadgets. How does your computer do very fast calculation? How does your calculator do it? The reason behind it, they don't deal with the decimal number systems. What we feed, what we give it to computer as input may be decimal, but there are certain circuits are there which converts decimal into binary. Bi means what? 2. It has got only 2 digits, zeros and ones. That's the reason the base is 2. Right, boys and girls? Now the third concept, the third number system is known as an octal number system. What is an octal means? Item number. The whose base is how much? Right. How many numbers are there? 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. So how many of them are there? 8 of them are there. That's why it's an whose base is what? 8. It's called as octal number system. And the fourth and the last number system is known as hexadecimal number system. As I told you before, hexa means 6, deci means 10. 10 and 6 would be 16. Whose base would be 16? Whose base would be 16? There are 10 digits are there, 0 to 9, as I told you here, same thing. Beside the digits, there are 6 alphabets are there. The first alphabet A denotes the value 10, B denotes 11, C denotes 12, D denotes 13, E denotes 14, and F denotes 15. So 0 to 15, how many of them are there? 16. Is this clear? There are 4 number systems computer use, okay, which are very, very familiar, right? But what we use, what we give it to computer and what we get it as, they are all decimal. Internally, they work on binary. If required, you can use them as a octal or hexadecimal, right? I wanted you to tell you what you are familiar right from LKG. You are in class 7. You are there. You are doing your schooling for the last 8 years or 9 years, right? 9th year. Right from the kindergartens or they call preschool onwards, right? You have been familiar only with the number system. I'll give an example to you so that you'll understand very fast, right? Here is an example. How much is this? 358, right? How do you know that? There are 8 ones are there, 5 tens are there, and 3 hundreds are there. Your teacher must have taught, your mathematics teacher must have taught. Units are ones, tens, hundreds, thousands, 10,000s, lakh, 10 lakh, right? Then crore, then keep going like this. What is that all about? 10 to the power of 0 is 1. 10 to the power of 1 is 10. 10 square is 100. 10 cube is 1000. 10 to the power of 4 is 10,000. 10 to the power of 5 is 1 lakh. 10 to the power of 6 is 10 lakhs. 10 to the power of 7 is a crore. And goes on. Why it is called as decimal number system? Most of you must be, the moment we write the number, you can immediately tell what is that value. But in mathematics, there has to be some proof. How will we say it's 358? I'll prove right now. How many ones are there? 8 ones are there. 8 into 10 to the power of 0. How many tens are there? The place value and the face value has to be multiplied, then sum them up. That's what I am doing. Am I sounding very difficult? Let me repeat again. The place value and the face value has to be multiplied and sum every digit, then you get the answer. Right? Here, what is this? The teacher must have taught ones, tens, hundreds. How do you get that 1? 10 to the power of 0. How do you get 10? 5 into 10 to the power of 1. Then 3 into 10 to the power of 2. Do you understand? Any number raised to the power of 0 is 1. 8 into 1. 10 to the power of 1 is 10. 5 tens are 50. 10 to the power of 2 is 10 into 10 is 100. 100 into 3 is 300. 300 plus 50 is 350. 350 plus 8 is 358. Do you understand, boys and girls? Do you understand? I repeat again. I will make it still simpler. This and this, are they same? Yeah, I repeat again. Units, some other they say units, some other they say ones. Matter is, unit means 1. Units, tens, hundreds, thousands, 10,000s and so on. Why it is called as decimal? As I told you, decimal means how much? 10. The base is 10. 10 to the power of 0. 10 to the power of 0. 10 to the power of 1. 10 square. If you have one more digits, 10 cube, 10 to the power of 4 and so on. Right? As you all know, 10 to the power of 0 is what? 1. 10 to the power of 1 is 10. 10 square is 100. Multiply this and this. I into 1 is I. 5 into 10 is 50. 3 into 100 is 300. 300 plus 50 is 350. 350 plus I is 358. So, did I do? Why it is called as decimal? Because we use base 10. Base 10. Is it clear? Now I am going to give one example in binary. Now I am going to give an example in binary. Is this clear? Yet again, binary would be a still simpler job. Right? Where the base would be how much? 2. Instead of writing here 10 to the power of 0, 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6 and goes on. And goes on, right? If it is 2. Mind you, boys and girls, in binary you will be using only 0 and 1. No other digit is used. The moment you use the digit 3, or if you use the digit 7, or if you use the digit 6 or 9, it's not a binary number. Binary number should have zeros and ones. Similarly, what is an octal? Octal number should have 0 to 7. There is a digit called as 8 and 9. If you use in octal, it's not an octal number. It's an invalid octal number. Right? This is strange. Hexadecimal. Not only the numbers, you also have the alphabets. Mind you, alphabets means not all the 26. It is 6 alphabets. A to F. A, B, C, D, E, F. That's it. Right? Now I am going to teach you the binary numbers and the decimal numbers. Decimal numbers you are very, very conversant. You are very, very familiar. What I want to teach you today is how to convert decimal to binary, binary to decimal. Should I repeat? Should I repeat? How do we convert decimal to binary and vice versa? Binary to decimal. Should I? Should I go ahead? Yeah. I'll repeat again what has been done so far. Right? We have done so far 4 number systems. What we use is only one number system in our day-to-day life. It's known as decimal number system, right? Whereas your computer, name it what do you call palm top or desktop or what do you call laptop or a mainframe computer, all of them they use the binary number system. They are capable of using all the 4 number systems. What we give and what we get. As an input, what we give to the computer is there in the form of decimal. After processing what we get, it again is in the form of a decimal because we all are familiar only with number system, decimal number system. That's the reason. Done. Now what I want to tell you is, I wanted to introduce this binary. Right? Binary. Please, it's not a mathematical subject. Mind you, boys and girls, if you pay attention for a moment, the trick of the trade, I'll tell you where the secret is. If you can understand, if the dullest student can do it in a rapid fast, right? It's quite simple and easy chapter. Here I go. Right? What I'm going to teach you right now is binary number system. Binary number system. Binary number system will have only 2 numbers. What are they? 0 and 1. 0 and 1. Right? 0 and 1. What would be the base of base? Here we saw 10 to the power of 0, 10 to the power of 1, 10 square, right? Here in binary we will be having 2 to the power of 0, 2 to the power of 1, 2 square, 2 cube, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6 and so on. As we go from right towards left. Now I am going to do a simplest task. I am sure you guys will love it. I want a simple exercise. Simple exercise. I want you to convert. I'll teach you what it is. Whenever the subscript, whatever is written at the below is known as subscript. Whatever they write on top is called the superscript. Boys and girls, you need to learn these terminologies because you are a student of computer studies. You need to be familiar. What does it signifies? I wanted to convert the 43 of decimal, convert 43 of decimal to binary. What the subscript is? 2. If it is 2, what does it signify? Binary. If it is 8, it's an octal number. If it is 16, it's a hexadecimal system. Based on this, you can make out. If it is 10, it's a decimal. If it is 2, it's binary. If it is 8, it's an octal. If it is 16, it's a hexadecimal, right? What is the question is? Convert 43 of decimal to binary. Should I teach you? Quite simple, boys and girls. Very simple. What the number is given? 43. Keep dividing by 2 till you get less than 2. I repeat. Keep dividing by 2 till you get less than 2. Whatever may be the remainder. The remainder could be 0 or 1. That you must take a note of it. Should I? Yeah. Now, you divide it by 2. Right? 2 2s are 2 2s are 4. 2 1s are 2. Remainder is what? 1. Should I repeat? 2 1s are 2. 2 plus 1 is 3. 2 2s are 4. Again divide it. 2 1s are 2. Right? Or 2 10s are 20. Remainder is 1. Again divide by 2. 5 2s are 10, remainder is 0, minus. No matter the remainder is 0 or 1, you have to take a note of it. Again, 2 2s are 4, remainder is 1. 2 2s are 4, 4 plus 1 is 5. 5 2s are 10, 10 plus 0 is 10. 10 2s are 20, 20 plus 1 is 21. 21 into 2 is 21 into 2 is 42. 42 plus 1 is 43. Is this clear? Now, again divide. Keep dividing till you get less than 2. 2 1s are 2, remainder is 0. This is where most of the students make a mistake. 2 1s are 2, 2 plus 0 is 2. 2 2s are 4, 4 plus 1 is 5. 5 2s are 10, 10 plus 0 is 10. 2 10s are 20, 20 plus 1 is 21. 21 into 2 is 42, 42 plus 1 is 43. Take the answer from bottom to top. Bottom to top. 101, 101, 0, 1, 1. That's all. Should I do it? No problem. What is the, how to do it? From decimal to binary means keep dividing by 2 till you get less than 2. Is it less than 2? This is where you have to stop. Till you get less than 2. And whatever may be the remainder, you must take a note of it. Once your job is done, take the answer from bottom to top. Take the answer from bottom to top. Is this clear? I will do one more example. Should I? Here I go. This is the example 1. Here is example 2. Should I do it? Yeah. 97 of decimal to binary. 97. Keep dividing by 2. 4 2s are 8. Remainder is 1. 1 and 7 is 17. 8 2s are 16. Remainder is 1. I repeat again. Please note. 8 2s are 16. 16 plus 1 is 17. Remainder is 1. 4 2s are 8. 8 plus 1 is 9. Is this clear? Again divide this one by 2. 2 2s are 4. 4 2s are 8. Remainder is 0. 4 2s are 8. 8 plus 0 is 8. 2 2s are 4. Again divide this one by 2. 12 twos are 24, remainder is 0. The remainder you must write, boys and girls. 6 twos are 12, remainder is 0. 2 threes are 6, remainder is 0. Here, 2 ones are 2, remainder is 1. 2 ones are 2, 2 plus 1 is 3. 3 twos are 6, 6 plus 0 is 6. 6 twos are 12, 12 plus 0 is 12. 12 twos are 24 plus 0 is 24. 24 into 2 is 48 plus 0 is 48. 48 into 2 is 96, 96 plus 1 is 97. Did I do it? This is where most of the boys and girls, 2 ones are 2, remainder is 1. Take the answer from bottom to top. What is that? 1, double 1, 4, 0, 1. Double 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 1. That's it. Is this clear? Right? I will be doing more problem in the following class, in the next class. Right? Boys and girls, kindly go through chapter number 2 of page 18. Go through this. There are 4 number systems: binary, octal, decimal and hexadecimal. Where binary will have base 2, octal will have base 8, decimal will have base 10 and hexadecimal will have 16. Right? What did you do it? We are converted from decimal to binary. Here are the 2 examples. Copy down in your notebook. Copy down in your notebook. We will be doing more problems. We will be doing more problems. I will check in particular class 7C. I will check your notebook. Right? I will tell Mr. Kevin to check class 7A and 7B too. So this has to be in your notebook, right? Okay, kindly go to chapter number 2. Till then, bye bye. Take care, boys and girls.